Everybody, my name is Lijun Zhu. I'm the CEO of CoEvolution Technology. And today I'm honored to talk about some of the work we've been doing in smart, flexible logistics solutions. And before we start, I want to show everybody a video about a project we did in South Korea. It's a cross-border e-commerce warehouse. And so this is just a time lapse of our project. So this is installing the shelves, and then we installed the robots, and the robots will automatically replenish the inventory and the totes on the shelves. And in this project, we used 3 different types of robots, and they collaborate to achieve a high throughput and high storage density solution. And you can see that different type of robots are running in the same field. They're collaborating with each other. And human operators, they have very easy UI and easy interface with the robotic system. So basically all the inventory will come to the human operator. They just pick whatever is needed based on the order. And then the robots will store the inventory. So today's talk is about smart, flexible logistics. We believe that in today's era, when we talk about logistics, we don't have the luxury of long planning horizon, because we don't know what's going to happen next year. That's kind of commonplace now. So we need a smart logistics system that's flexible. We believe that flexibility is the key to win in the next era. And we believe that needs to a revamp of the whole infrastructure in logistics and automation. And that's what we're doing. We are approaching this from a software point of view. We believe that AI and other software technologies are essential in this new era of supply chain and logistics. And our company is called CoEvolution Technology because we believe that flexibility is the key in the new era. So we name ourselves like CoEvolution because we want to co-evolve with our customers and our partners, because we believe the ability to adapt to change, the ability to evolve is the key. So it's just a little introduction to our company. We're based in Hangzhou, China, and we're a leading provider of smart, flexible logistics. And our core technology lies in software. It's not hardware. We're not a robotic company. We don't build robots. We don't build automation systems, but we build a total solution. We synergize robots from different vendors, from our partners. Right now, we're collaborating with over 20 different vendors. And our core engine is the robotic control engine and the robotic dispatch engine that can control different type of robots and let them collaborate to achieve a robotic warehouse system or a robotic factory system. And just a little bit background on myself. I actually had a background in physics, and I moved from physics to supply chain and logistics. And somewhat interestingly, I found there is a high similarity between physics and logistics. Okay, so on the left-hand side is what I did before in physics. It's a standard model of particle physics. It's a complicated formula, but that models the behavior of real world, the physical process in the real world, okay? And on the right hand is some project I did before. It's like, how do you optimally choose a warehouse based on your demand distribution? It's also a very traditional logistics problem. You also use a mathematical model to model, your future demand, your shipping cost, your warehousing cost, and how do you fulfill the demand with minimum cost. So from the appearance, they appear quite similar. And I myself find it very interesting that logistics, supply chain, and physics share a lot in common. For example, we're basically using mathematical models to model the real world. In physics, you're modeling the real physical world. But in logistics and supply chain, you're modeling the commercial world, how things move within the commercial world. Also, the process of doing it is quite similar. First, you do data gathering. You gather lots of data, and we model it using a mathematical model. And then we do an experiment. We try it out. We see if it actually, if the model actually works, and then we get some feedback. If it works, then we move on to the next model. If it doesn't work, then we go back to the board and write our new models. And also, it's optimization problem at its core, both in physics and logistics. We're trying to optimize something. In logistics, it's quite simple. We're trying to optimize costs. You want to have the highest efficiency with minimum cost. So, and also Elon Musk said that production, supply chain, and logistics are quite hard. So I believe him, okay? And it's really hard from my experience. It's a quite hard problem to tackle. So I came into this world of logistics back in 2011. So that was 10 years ago. And my first impression of logistics is like it's like a very giant and precise mechanical machine. It's like what Newton modeled the real physical world, right? It's a giant machine. You know the nitty-gritty details of how things work at its smallest scale, and then you kind of know what at large scale it will work. So, so my first impression of logistics, I joined Amazon about 10 years ago, and Amazon used a very sophisticated infrastructure, IT infrastructure to manage the supply chain and the logistics. Everything is calculated based on a model, and it's quite nice. It's quite beautiful. Okay. But after about 10 years, I don't think so. I think things changed a lot, okay? After some experience battling in the real warehouse and in the field, I found the world of logistics and supply chain is quite complicated, and it changes a lot. It's not a stationary system. It's not like something is fixed and you're just trying to optimize it. You try to work out the little details. It changes a lot, especially here in China, because the retail side changed a lot. Then it forced the supply chain and the logistics side to change a lot. And we actually hate change because you need long planning horizon to build an awesome logistics or supply chain system. So after a while, you can find that the logistics industry or the supply chain industry formed kind of an ecosystem. They collaborate, and then they compete with each other, and then they collaborate with each other to adapt to this change. I find this is quite amusing and quite fascinating. So I believe in the new era, especially post-COVID, change is the common thing. And we believe this will become more and more severe, okay, in the coming future. And fast changes pose great challenges to both supply chain and the logistic industry. And we as an industry, we're not prepared for this, to be honest with you, because the traditional thinking of logistics and supply chain is planning, planning, planning. But now we don't have the luxury to plan ahead because we don't have the lead time. Things change so fast. For example, from the retail side, we know that things changed a lot. First of all, we have the traditional brick and mortar retail, and then C2C e-commerce comes first, and then it evolved into B2C e-commerce, and then it evolved today, especially in China. You have live commerce, right? It's from TikTok or some other short video platforms, and we don't know what's going to happen next. And to cope with this change from the supply chain and the logistics side, first of all, we had the traditional supply chain and logistics network that handles the brick and mortar retailers. And then to handle to cope with the C2C e-commerce network, a parcel delivery network quickly evolved. It grew really fast. And then to deal with B2C e-commerce, a large fulfillment network come into existence, especially omni-channel fulfillment network. And that's only in recent years. And now people are talking about C2M, customer to manufacturer, like small scale production and quick and fast iteration of production and the supply chain. And we don't know what's going to happen next. And the pace just keeps increasing. So we believe that the ability to adapt to change will become the most important capability for supply chain and industry player and logistic industry players. So, and Charles Darwin once said that it's not the strongest of the species that survive, nor the most intelligent, but the most responsive to change. And that's what we're doing. Okay, we named ourselves CoEvolution, because we want to utilize technology to drive evolution in the logistics industry. So we believe that the ability to adapt to change is the core, and we can see that the need for flexibility is really rising. And we can find a comparison in the transportation industry, right? In like thousands of years ago, people walk, and that's the traditional way, right? People walk. And then the first industrial mobilized transportation system is the train. It's highly efficient, but it's very rigid. You need to build rails. And then people develop and invent the car. It's actually less efficient to some extent, but it's more adaptable, right? Everybody can drive their own car. And then in this new era, everybody uses Uber. You don't even need a car. It's like something on service. It's a transportation as a service. So also we believe that in the logistics, the movement of goods, the same thing will happen. Traditionally, everything is done manually. Everybody, human operators will move inventories within the warehouse between warehouse and trucks. And then the first thing that came out a few decades ago is hard automation, or the traditional automation. You use conveyor belts, you use ASRS, you use kind of rigid but highly efficient systems. These are okay if you can plan ahead, right? I mean, if you know what your business will be in a few years, you can plan ahead. You can nicely plan your warehouse or your factory and lay out all those conveyors, all those ASRS, those shelves to fit your need in the future. But we don't have that anymore. We don't know what's going to happen in the future. So the rise of flexible automation is quite significant. A lot of customers, like from our experience, a lot of customers, they don't know what's going to happen in the future. And so they would choose flexible automation based on robots. And then you don't have physical fixed infrastructure in your warehouse or your factory, and you can change it. You can adapt it to your future business needs, okay? And we believe in the future, we also might have smart warehouse as a service. And that's just something to ponder about. So we believe that the features of the next generation smart logistics solutions is intelligence and flexible and efficient, okay? So the traditional automation system, the one that based on conveyor belts and other fixed infrastructure, is usually based on automation technology. Okay, that's different from a robotic or AI technology. Automation basically is a fixed line, fixed production line, or fixed transportation line, and you use fixed logic to move inventories, to move goods around within your warehouse or between your warehouses. But we believe in the new era, because we use robots, we need to adapt to changes. We have to use AI-powered smart systems. And in the beginning, we also mentioned that logistic problems, optimizations are hard. So we need to use these AI systems, these AI technologies to solve these hard problems. And that will significantly reduce the problems caused by human operators and management. So we think that the future of smart logistics solution will be AI powered, less intervention from human. And another feature should be that it should be very flexible, okay, because we need to adapt to change. So you should be able to deploy easily within months, okay? And also, if your business changes, it should be easy to change the system and to adapt it, to re-optimize it. So to achieve that, we need to use less fixed infrastructure and equipment, and software will be the key. It will be the key to adapt to the changing business environment. Basically, you reconfigure your software so that your new system can adapt to your new business need. And based on that, we think that you need multiple robots collaborating to achieve your end business goals. Okay, so not fixed infrastructure anymore, but different kinds of robots. They work together and the software behind the robots is the key. Okay, so we need the technology, multi-agent or multi-robot planning. And the whole system, based on the AI technology and the multi-robot planning technology, the system should be highly efficient. And even though we use automated system for factory or warehouse, we still have human operators. We need to have synergy between human operators and robots. And the robots also need to collaborate with themselves. So the system architecture somehow should be modular, okay? Like robots will do what it does the best. Different robots will do what it does the best, and human operators will also be involved in the process and does what it does the best. And these modules will combine to form the complete solution. And the challenge for the next generation smart logistics system is that it's highly complex. Because the business use case is highly complex, we need a lot of customization, different warehouses, different factories, they're quite different. And different projects usually have custom-made systems, and they cannot learn from each other, basically. The optimization you achieved in one warehouse or one factory can hardly be used in another. And we have to use a large number of different type of equipment, different robots, different automated system and equipment. So, and we know that hardwares, they're prone to error, okay? Things break down a lot, okay? So we need to be robust somehow to be robust to things that can have errors or exceptions. And that's quite hard. And also we know that from technological point of view, AI algorithms, when you want to optimize it, you need to feed in a lot of data. But right now, you know, different projects, different warehouses or factories, their data are segmented, right? Like even within a warehouse or within a factory, different parts of it are segmented. You cannot use the data holistically. So it's hard to train your model, to train your system to be smart. So that's why we believe the future of smart flexible logistics needs to be integrated, and different type of robots will be specialized in a way. So different type of robots will handle different tasks. But then we have a centralized system that's like a platform that will control all the robots. Then this platform can gather all the data in different parts of the warehouse and in different warehouses. And then the model and the optimization engine used in that smart robot control system can evolve. And we borrow this from a traditional mechanical automation point of view as well. The traditional mechanical automation solutions, they usually integrate equipment from multiple vendors. That's the standard today. It used to be that, you know, hardware vendors, they will build a system, they will build a solution, but it's no longer the case. Integrators, they would build a system. They would integrate equipment from different vendors. So when we replace this traditional mechanical automation with robots, we believe the same thing will happen. We need a new kind of platform that can integrate different kinds of robots and let them collaborate with each other. So that's what we're doing. So we're trying to build a robotic industrial and logistic solution platform to control different kinds of robots and make them collaborate with each other. So the traditional way to do it from an integration point of view is on the left hand side. So the integrator, basically, they will buy robots from different vendors because, you know, different vendors specialize in building different type of robots. But they also buy their system because robotic control is hard. Okay, fleet management is hard. Integrators usually cannot do that. It's a software problem, it's an optimization problem, it's an AI problem. Okay, and integrators usually they just buy off the shelf individual solutions from robotic vendors or automation vendors, and then they integrate on top of the vendor system their own system. Okay, so it's like a system on top of system kind of structure. This is on the left side. So the data are not shared between the systems. So like the appearance of one robot cannot be like one system does not know the existence of robots in another system. Okay, so in CoEvolution's integrated control system, we gather all the data in one system. We use one system not only to gather the data, but also optimize the overall flow. And that solves a lot of problem, okay? So in the traditional way, when you have multiple type of robots, because the system are segmented, they're separated, you have to physically separate them, okay? For example, if you have a warehouse that has different types of inventory, some inventory you can put in a tote, some inventory you can put in on a shelf, some inventory you put on a pallet. So on the left-hand side, you would buy 3 different types of systems from 3 different vendors. One is tote-based automation, one is shelf-based automation, and another might be pallet-based automation. They usually from different vendors because different vendors specialize in building different robots. They have to be segmented because the systems, the data are not integrated. The system is not integrated. You use separate system to control separate robots. They don't know the existence of each other. So the space utilization is low. Also, the efficiency is low also because you have to kind of, you're putting a lot of constraints on designing the solution. And that, because of that, it's hard to optimize the whole overall workflow. So if you use an integrated system, like a CoEvolution system, we can control multiple type of robots, regardless of the vendor, regardless of the technology used to control or navigate the robots, regardless of their functionality. We can control the whole fleet holistically. And like go back to the example we talked about, if you have totes, if you have pallets and shelves, we can merge them together. They can exist in the same field. And we use only one system to control and optimize the whole workflow. So this synergized control of mixed fleet, we can usually increase the system efficiency by 20 to 30%. And it also is highly adaptable. If you want to add a new thing, it's easy. So the system architecture, we believe, is going to be something like this. On the upper layer is a customer system. There, if you run a warehouse, is a warehouse control management system, and if you run a factory, is your manufacturing execution system, a MES. And then our system has different layers. Our the top layer is a warehouse control system, WCS. It handles the order management, inventory management, inbound, outbound strategy, or some user interface. So it handles the business logic and the optimization of different resources, allocation of different resources within your warehouse. And we also have a very platform-like open robot control system called RCS. It handles the task allocation, task scheduling, and for mobile robots, path planning and traffic control for the robots. And we use the interface layer to interface with different kind of robots and equipments. The interface is standard, but the vendors does not have to conform to the standard. We'll do the translation. So like the control command and status data we'll gather from the robots and then do optimization based on this data and send command to the robots. We will do the translation to fit to the protocol used by the vendors. And on the bottom layer, the vendors will provide different types of robots and equipments, either AGV or AMR or robotic arm or a conveyor. Yeah, so our products are basically software, okay? But we build turnkey solutions to end customers. So the products, our software products have 3 different products. One is the RCS, is platform, and the WCS handles the business logic of your warehouse or your factory. And then on top of that, we have a simulator to simulate the workflow of your warehouse, of your automated warehouse or your factory, and see if there's a problem during the planning phase or if you want to improve it. We know the way to optimize the whole system. So our RCS is very special in the way that it's actually the first, we believe is the first in the industry that it's quite open. It's like a platform that it integrates different type of mobile robots. And we use a software interface to directly control the robots, circumventing the system provided by the vendor. And that is quite essential because after that, you can have real synergy between different type of robots in the same warehouse, and you can build solutions that you couldn't build before, and which are highly efficient and low cost. And also we can, as we said before, the system can support robots from different vendors with different navigation, different functionalities. And then we'll merge, the different mobile robots, their map representation, and merge them together so that they can run in the same field. So these are some of the projects and some examples we did. So on the left side is the video we showed, is the e-commerce, cross-border e-commerce warehousing in South Korea. And we use different type of robots. As we said before, we use 3 type of robots to achieve it. And there is a big robot that carries the tote between the shelves, and a small robot that carries the tote to the workstations. They collaborate. So it's basically like a dynamic inventory allocation. Okay, so we know that in e-commerce, we have the 80-20 rule, right? About 20% of the products will cover about 80% of your sales volume. And that's very, very common. So to build a suitable solution for the customer, we use this this design so that most of the inventory is located on the lowest level of the shelf. And that's the inventory that's needed. That's the hot inventory, the fast selling inventory. So you only need to use this small robot to carry that inventory to the workstation. And the large amount of inventory that's slow moving, that's hardly selling, we'll put it on the high shelves. That saves a lot of storage space. And then this big tote robots will shuffle the inventory between high shelves and the lowest level of the shelf. So it's basically like hard drive and memory kind of concept, right? The data you need is usually stored in memory, but the large amount of data is stored in a hard drive, which you don't need, okay, but you might need sometime in the future. It's the same concept, and we can achieve this concept quite easily because we have an open robotic control platform. We can just buy robots from different vendors and then assemble them to achieve this layered architecture of inventory distribution. And the same thing in the middle is a traditional warehouse that use also high shelves to store the inventory, and also most of the inventory needed during the day is stored on the first level. So we use the high automated forklift that can retrieve pallets on the high shelves, and then another Kiva-like small robots to carry the inventory to workstations. Also use a collaboration between robots from different vendors, different manufacturers. And also you can achieve high throughput and high storage density with much lower cost. And on the right-hand side is also a combination of different type of robots. The big one is used to transport the finished product, which is a vending machine. It's quite large. And then the small robot, the blue one, is used to transport the parts within the factory to the assembly line. Okay, so they also have to collaborate within the same warehouse, and they're also from different vendors. Okay, so we believe this synergized mixed fleet control and management is the most efficient way to do a smart warehouse or factory solution. We use the right robot to fulfill its most suitable task. We're not overusing them, okay? And it significantly increases system throughput and the robustness. And our WCS, the warehouse control system, is a smart logistic control system. Is basically divided into two different kind of products, two different kind of solutions. One is in factory, we call it R-Star, and another is in warehouses, we call it CoPeak. The CoPeak solution in the smart warehouse, we have seen videos of it. So it's basically, we are combining different type of robots to achieve high storage density and also a high throughput. And we can, the products can be tote-based, can be pallet-based, can be shelf-based. Doesn't matter. It depends on your business needs, like customers' business need. If they need pallet, we can use pallet-based solution. If they need shelf, we can use shelf-based solution, and then we synergize them and put them in the same field, and use one system to deploy and control everything. And our R-Star Smart Factory solution is to build a smart factory intralogistic system. And you can, the customers or integrators can use our software to configure the business processes, how products and goods and inventories move within the warehouse. And they can just configure the workflow, and we will control the robot. We'll deploy the robotic fleet to achieve the whole workflow. So they will design the workflow, and we implement it using our system. And the simulator also is quite significant, is quite important, because in a lot of automation project, the key is to know like what's the throughput, what might be wrong in your system in the future when things change, right? I mean, if you use a simple calculator, it's very hard to actually calculate the total throughput of the system because it's quite dynamic. It's a very complex system. So we use automation simulation to do it. Basically, we simulate the details of the workings of each robot, how it accelerates, how it picks up inventory, how it moves to its workstations, how it stores inventory. We use the actual control and the engine. We use the real RCS, WCS, our control engine that runs in the background, and then we'll simulate how the robots will move. So then during the planning phase, we can quickly know what's the throughput of the whole system, and it's highly accurate. This is a very important tool to build automated solutions. Otherwise, you might spend a lot of time and money to invest in an automation project and it doesn't work. That happens a lot. So yeah, these are some of the videos of the projects we did. This is a e-commerce cosmetic warehouse in Hangzhou, in China. And you see that a lot of the small totes robots are bringing the totes to the workstations. The workstation is basically just a touchscreen computer that directs the operators where to put the inventory. And you see that on the left side, there is a high tote robot that moves, that hardly moves out of the aisles. So it just handles the up and down movement, the reshuffling of the inventory within the aisle. And this is the project of an electronics factory parts warehouse. It supplies electronic parts to the factory. It's a laptop factory. And we use two different kinds of robots. One is an automated forklift, and one is a small Kiva-like robot. And they will collaborate. The automated forklift will bring the inventory from high shelf to the lowest level. And then the small robot will bring it to the workstations. And you can see that they're really running in the same field. They're really collaborating with each other. And this is just a cross-border e-commerce warehouse. I'll skip this video. And these are some of the other scenarios, some of the other solutions we did before. Like on the upper left is a construction material factory that builds, construction materials. We use like big, giant automated forklift to do the transportation within the factory. It's highly automated. And on the upper right corner is a retail warehouse. This is actually Lotte in South Korea. This is the part that handles the replenishment of inventory to the stores around Seoul. And this solution had around 40 robots that carries the totes, that brings the totes to the operators, and the operators will pick inventory from the totes. On the lower left is a automobile parts factory. So we use also two different kind of robots. This only shows one here, but it's a roller robot that transports the parts, and another automated forklift that transports the finished product. And on the lower right corner is the e-commerce warehouse in Shanghai that use basically Kiva-like robots to bring the inventory to the human operators. And we also have lots of partners. So most of the top robotic makers in China are our partner, like Hi Robotics, Quicktron, Standard Robots, Mushani and Geek Plus, HIK, etc. And also some of the top, some of our large customers, they understand that they need flexibility in the future, so that they choose to work with us, because otherwise they don't. When you buy the robots and use the system provided by the robotic manufacturers, you are inevitably coupled to that robotic vendor, because it's very hard to expand. It's very hard to adapt to change in the future. So to use an open system like our solution is highly ideal for them. Like Huawei, like Lotte and Lenovo, these are some of the big customers. They have tried individual robotic solutions, and now they want to expand. And they believe that using a synergized open system to control all the robots is the key for success in the future. So yeah, so to sum it up, we believe the next generation of smart logistics need collaboration from different partners, and we focus on software. And we believe that's essential for the success of this technology in the future. And we strive to co-evolve together with our customers and partners based on our AI-powered software technology. Okay, thanks a lot. And I'm happy to discuss with people with questions.
Let me kick off the questions first then. So my question is, what are some of the current automation trends that you observe based on some of the data you've collected from your current projects, or even just in the market in general?
Yeah, I think so. Either in logistics or in manufacturing, I think the trend for automation is quite obvious. Like customers, they look for automated solutions because of the shortage of labor and the change in business demand. But people used to put a lot on the cost and the planning. Like they usually take a long time to install a project. Also, they also like focus on the total throughput or the efficiency of the whole system. Now they are focusing more on the adaptability of your solution, because people are not sure how to plan for the future, and that's quite significant change. And so that drives the shift from traditional fixed automation or mechanical automation into this new era of robotic automation. But during this stage, I think most people still don't understand, or still are trying to use some robotic automation or robotic solution in their warehouses or factories. They're still during the demo phase. But big players or big users or sophisticated end users, now they have tried the demo. They have tried the individualized robotic solutions, and they understand it now that they need to integrate the different kinds of robots into one system. Okay.
Yes, thank you very much for the presentation and the interesting subject. How far and how difficult do you think we are from being able to transpose the warehouse to a city?
how far do I think it is to transpose it to a city?
Yeah, the warehouse may be transposed into a city. I mean, it's very similar.
Yeah, it's
So
very similar.
how far do you think we are from this being possible, and how hard do you think it is?
I think it's actually easier to manage a warehouse actually, because it's quite confined, right? I mean, the problem itself is not, the problem size is not that difficult. It's not that hard actually. So I think there's a essential difference between a city and a warehouse or a factory. So boundary of a warehouse and factory is confined, and what's stored within there is confined. We can use centralized planning, and that's what we've been doing. Okay, our software use centralized planning. So the robots or the humans, they just execute the tasks that's sent by the centralized planning system. We can use centralized planning for everything within a warehouse because the problem size is not huge, right? You have hundreds of warehouses at most, or you have hundreds or even thousands of workers at most. But at that size, you can still optimize centrally, right? I mean, you can basically write down a model and optimize it, okay? So that can be done. And it is done actually in some of the best automated warehouses, okay? So everything is centralized, it's planned, and the robots or the human workers, they just execute the plan, and it's highly efficient. But for city, you really need a distributed intelligence. You cannot use centralized intelligence, right? Everybody or every player within a city.
I know we interested in you, your company a long time ago. First time I talked directly with you. Excited to hear about what you were doing and what you did before as well, because I myself did some quantum cosmology, a lot of simulation with the basic physics formulas like yours.
Really?
Yeah, and then now I'm handling similar problems to yours as well. Basically, I don't know whether Jay told you about Neuron, the company that I'm now running in Hong Kong. Basically, the smart building system that we have developed. And then we also face similar problems. We have a chart similar to yours, talking about how we decompose the main system into the modules and try to fit them together to solve different problems. I noticed that I wanted to ask two questions here. One, you talk about simulation. You would try to use your AI, your systems to simulate different scenarios for clients and try to help them to resolve different problems at different times and probably help them to evolve with the situation. I think that is a very noble cause. But then that itself means that your system is never very stable. So my first question really about knowledge transfer. Once you implement a solution for your clients, how do you make sure that the system will be upgraded at the right time, at the right interval? Because if you want to do that, that means you would have to have continuous liaisons and discussions with your clients, and that would be bad for your own business. So that really is my first question: how you optimize your time, helping them to simulate and upgrade versus standardizing your product, standardizing your system so that people can easily use that. But then once it's standardized, then it's not as flexible and it cannot evolve. So how do we solve that problem? My second question is about your what do we call it? Onboarding time. Do you only work on big projects for clients, and then you have to study and take weeks or months before you can deliver the product? Do you think about standardizing it for smaller warehouses, like smart manufacturers who would have a rather standard problem for you to resolve for them?
Okay. Yeah, thanks, Thomas. I think these are very interesting and very helpful questions. So first of all, about your question about simulation and about the product, how do you productize your system and how do you cope with the evolution and on that. The approach we're trying is we're building tools. Okay, so we're not building, we don't believe we are a product company. We're not building products. The product companies are those robotic companies. These vendors, they build a very awesome robots and that just can be used anywhere. That's a product, but we're not building products. We're building solutions. And of course, we don't have the domain knowledge to build solutions in all domains. That's impossible. So we build tools, and the tools are the baseline. So like our RCS, the robotic control system, is one of the tools that we use to build other solutions on top of it, okay? Either in a warehouse or in a factory. Like some of the examples we show in the slides, we have solutions in all kinds of weird, different use cases, right? Different industry, different warehouse, different factories, because we have an awesome tool. I think that's important. We're giving this tool to integrators or consultants. So we rely on them to deliver the solution in some industries, like in the automobile parts factory. We have no clue how the factory works because we never worked in the automobile parts factory. We know warehouses quite a lot because it's quite standard, and we used to be in the industry. But automobile parts or the construction material factory, we have no idea. There was an integrator or a consultant that designs the project, and they just use our tools to deploy it because they lack the capability to deploy it. In the good old time of mechanical automation, they can do it, right? They know a lot about conveyor belts and all that. They can do that. But right now they use robots. They have no way how to control and dispatch and do fleet management, do all these different kind of type of things. We provide a tool for them, and because of that, our capability grows significantly because we understand, like, to use in this factory what kind of function we need to add to our system, so they can use it to configure for new projects. Okay, so in some industries, we're not delivering the solution at all. They are delivering the solution. Our partners are delivering the solution, but we provide the basic tools so they can use it. And after working with them a lot, they evolve, right? And they evolve, our functionalities evolve, our tools evolve, okay? Mm-hmm. So we will have more and more functionality within the tool. It's not like an auto CAD, right? I mean, I don't draw the drawings. I don't design a plane, but they can use auto CAD to design a plane. Also, in manufacturing, they use our tool to design a flexible automated factory. We don't have that capability. We don't have that domain knowledge, but we gave them the tool. And they tell us what functionalities are needed in that tool. So our capability also grows. Yeah.
Right. You don't only give them the tool, you also choose the different robots for them to use, because even if they are domain experts, they don't know the robots as well as you do. Right?
Exactly. We give them guidance, but they will buy the robots sometimes. Actually, on the left-hand side, these are the cases they buy the robots. We don't even own the robot.
Thank you, Lijun.
Vincent. Yeah, thank you, Vincent.
I think if you ask me about my passing thoughts, is we found CoEvolution very interesting for several reasons. Number one, it is in the supply chain. Number two, it is about AI. Number three, it's about robots. Number four, it's actually a very low-cost way to test, shall we say, electric vehicles. Because the problem with electric vehicles outside in the big wide world is that, they're a lot more problematic, whereas inside a control environment of a warehouse, a lot of these software is actually helping navigate these robots. So that's why we thought it's very interesting, where you cross supply chain and AI and robots and vehicles. That's why we're so interested, Lijun.
Yeah, never thought about it that way though.
It is.
Yeah, you're right. I think you're right. Yeah, I think all the technology that we plan to use in the big wild world, we should try it first within the walls, right?
Exactly.
Yeah.
And also because if you think about it, all four are very difficult problems, right? You said it, supply chain is difficult, AI is difficult,
Yeah.
robot is difficult, and so is vehicles. But now we put it in a control environment, which is the warehouse. I think it actually will help, literally, as you say, evolve these systems much quicker, much quicker. And it's almost like, you know, in every car that in every product that you produce, right? You always start from the laboratory, and the warehouse is your lab.
Exactly. Yeah. Exactly. So the way we operate, because we're focused on software, so the cost is not that high. Yeah. Yeah, the way we run our business, because our central product is the software, so it's not like it's not very heavy. You know, it's not like we're investing a lot in the supply chain.
AI companies burn money like no tomorrow. Burn money like no tomorrow. It's just crazy.
Yeah.
Especially when you said, "Oh, it's only software. How much money can I?" Oh, I tell you, you know.
Yeah, I understand. Yeah.
So anyway, so thank you very much. Thank you very much.
Thank you, Vincent. Yeah.
Okay, with that, we will close today's session. Thank you, Lijun, and also thank you, Vincent, for your closing thoughts. And thanks everybody for joining us today. So we'll see you in the next Venturous session then. Thank you.
Yeah.
Thank you.
Thank you.
Thank you. Bye-bye.
Bye-bye, everyone. Bye-bye, Thomas.
Thank you.